Hi, I'm Mehak Dimesh, and I'm an applications engineer at National Instruments. What we are demoing today is the digital filter design toolkit, and basically what that does is it helps design filters for DSPs or FPGA targets. What you can see here is basically, and I have stopped the music right now, but we have a filter that's been designed to cut out 2 kilohertz worth of 2 kilohertz frequency noise from the signal. So what we're doing is we generate a signal, we take the input, we add the noise to it, which is 2 kilohertz, and we have a filter designed on the FPGA on the backplane of this chassis that cuts out that 2 kilohertz noise. So without the filter on, that's what the signal would sound like. So that filter is being designed with the help of the digital filter design toolkit. These are the steps that are involved with designing the filter. So as you can see, this is a demo of how you can use the DFT toolkit, and this is a floating point in design and analysis where you define your filter, you define what are the frequencies that you want to stop. In this case it's a notch filter, so you define the center frequency, which in our case is 2 kilohertz, that you want to cut out, and any bandwidth around that frequency that you want to cut out from the signal. And you can give different kind of specifications here. As you go through the design process, it takes you to the floating point filtering part, where it shows you, based on what you gave in, what the unfiltered signal and the filtered signal would look like. The structure and selection and coefficients quantization part basically takes in some more values from you, and it gives you the coefficients required for the filter, so you don't have to calculate them. So basically what you put in is the precision and the bit precision of your signal. In this case we're using a 16-bit signal with 1 bit assigned to the integer word length, and based on those values it actually calculates the coefficients that you need for your filter. So you don't have to do the math yourself, it's all been built in for you. This part actually shows what a signal would look like after it passes through the filter. Basically, so in this case we've designed it to be a 1.8 kilohertz bandstop filter. So if I put in, for example, 1.8 kilohertz, actually here, sorry. I think it was the key was on that button, so when I pressed enter. So in this case, 1.8 kilohertz signal, you can see the responses. It's going to cut out most of that frequency from that signal. So, and if you go to this part, it generates the code for you depending on the platform you're using. For example, in this case it's the FPGA. So this is an example of FPGA code that you can put on any of the NI targets that use an FPGA. So you can put your own signal conditioning on the FPGA, or you could generate C code for it, which actually allows you to put the C code on a DSP that you may have bought from a third-party vendor or things like that. So this is these are the different steps, so you don't have to go through the intricate filter design equations anymore. You can just put in the specifications and use it as it is.